In this video, we will be proving a property of a special quadrilateral. Look at this quadrilateral ABCD. Sides AB and CD are parallel to each other, and the non-parallel sides AD and BC are equal. This is the data that is given to you. You may or may not be given the name of this quadrilateral. Seeing that we have one pair of opposite sides parallel, you should be able to say that it's a trapezium. And since the non-parallel sides are equal, we can say that it is an isosceles trapezium. But what do we have to prove here? We have to prove that AC is equal to BD, which means we have to prove that the diagonals are equal. How do we prove these two lengths equal? Whenever we have to prove two sides equal, we generally have to prove that any two triangles that include those sides are congruent. So if we prove that triangle ADC is congruent to triangle BCD, we can conclude that AC is equal to BD. And according to the data given, we have AD is equal to BC. And DC is the common side. So if we somehow prove that angle ADC is equal to angle BCD, we can say that the two triangles are congruent by the side angle side condition. Just by looking at this figure, we cannot say anything about the two angles. So we modify the figure slightly. We can drop perpendiculars from A and B onto DC. This is a perpendicular from A onto DC. Let's call it AE. And this is the perpendicular from point B onto DC, and let's call it BF. Now focus on these two triangles, triangle AED and triangle BFC. If we prove these two triangles equal, then we can say that angle ADC is equal to angle BCD. Note that the two triangles are right-angled triangles. We know that AD is equal to BC. This data is already given. Now this is the interesting part. We can also say that these two lengths are equal. The distance between two parallel lines is always equal. We can say AE is equal to BF. That's because altitudes between two parallel lines are always equal. So in the two right triangle, the hypotenuse and one of the other sides are equal. So triangle AED is congruent to triangle BFC by the right angle hypotenuse side condition. So we can say that angle ADE is equal to angle BCF. They are corresponding angles of congruent triangles. So we have now proved these two angles equal. Now let's focus on these two triangles, triangle ADC and triangle BCD. Let's redraw these two triangles so that it becomes a little easier. Triangle ADC looks something like this, and triangle BCD looks like this. Side AD is equal to side BC, so we write AD is equal to BC. This angle is equal to this angle. Angle ADC is equal to angle BCD. This and this is actually the common side to both triangles. DC is equal to CD. So triangle ADC is congruent to triangle BCD. We use the SAS or side angle side condition to prove it. We can say that AC is equal to BD as they are corresponding sides of congruent triangles. We have proved what we were asked to. But what exactly did we prove? We proved that diagonals of an isosceles trapezium are equal.